Welcome and thank you for your time. Today I'm going to discuss a different approach to data security that begins at the start rather than the end of the development process. As a software developer, you may be asking, why should I care about data security? Well, it's highly likely that the applications that you're working on now or will be working on in the near future will be subject to some type of data protection requirement. Privacy and security regulations around the world, such as the General Data Protection Regulation, California Consumer Privacy Act, Health Information Portability and Accountability Act, etc., increasingly require that identifying and other sensitive data be protected on every device that stores it and in transit every time it is sent. And many regulations now provide data owners with additional rights in regard to how their data is used, where it is stored, and how long it exists. The number of data protection and privacy regulations continues to increase with stricter penalties for noncompliance. In 2020, penalties under the General Data Protection Regulation alone totaled $191.5 million. The International Data Corporation predicts that by 2025, 90% of all data created globally will require some level of security. Despite increasing annual expenditures of hundreds of billions of dollars and millions of man hours of labor on cybersecurity solutions, the number and magnitude of data breaches continues to increase every year. Data breaches can put companies out of business, targeted attacks can halt operations, and attacking can compromise trade secrets. In 2020, there were nearly 4,000 data breaches that exposed over 37 billion records. The average cost of a data breach in the United States is $8.6 million. Cybercrime cost businesses over $2 trillion globally in 2019. And perhaps an even more chilling statistic is that 60% of small companies go out of business within 6 months of falling victim to a data breach. So with so many solutions available and so much attention on cybersecurity, why do we keep failing? The vast majority of cyber solutions still focus on network or perimeter security, i.e. protecting the data location. Some examples include firewalls that restrict access to networks and encrypted internet connections that are about protecting network traffic, or encrypted disks and folders and databases that silo data and protect it in storage. But what are people really trying to steal? Data. Why? The data is what's valuable. Data is generated by software applications running on the myriad of devices we use every day: personal computers, smart home devices, mobile phones and tablets, servers, etc. Data is typically stored on the devices running the applications for local use. It is then copied and distributed to other devices via the internet or other media for backup, synchronization, and sharing. This process results in an unknown number of copies utilized by an unknowable number of people or systems. The only effective and efficient way to solve the data security problem is to protect the actual data at the source, the software application. After all, software is what generates and processes digital data. If security is applied to the data at creation, that protection can be maintained throughout the data's lifecycle, regardless of where the data travels. So where do we typically discuss security in the software development lifecycle? At the end of the lifecycle, deployment. Historically, data security has been an afterthought, something that others will handle. The IT team will handle it. The IT team will handle it after our software goes live, or the client will handle it with their own hardware. In today's environment of large-scale data breaches and increasing regulations, data security as an afterthought is too little, too late. Waiting until deployment to think about data security can also lead to software usability and access problems. First, it often limits software architecture options when you're forced to rely on infrastructure security and or third-party services. Are you designing your applications based upon the IT or information security department's requirements? Or are you choosing the best architecture for your application to optimize flexibility, scalability, or user experience? While cloud computing enables organizations to more rapidly scale and efficiently utilize IT resources, it also forces organizations to rely on third-party services to provide reliable and secure access to their data. With the growth in cloud adoption, data security, cost optimization, and flexibility are becoming increasingly important. Enterprises and software application vendors are looking to break free from siloed dependencies on a particular cloud provider and for the ability to move applications on demand between public and private clouds to the edge compute locations to better serve the needs of their customers, mitigate service disruptions, risks, and reduce operational costs. One of the biggest reasons security usually takes a back burner is because of its potential impact on application usability and or performance. If the application needs to be, if data needs to be encrypted, how is your software gaining access to keying material to decrypt and read the data? Does it have to call a central key server for every cryptographic operation? How does that impact performance and user experience? If you're relying on a third-party service to verify and encrypt data, do they have access to private keying material? What additional compliance and security concerns might that cause? And as workforces become increasingly mobile and global, data is generated and needs to be instantly available across a multitude of different devices. Are you relying on transmission security alone to protect data once it leaves encrypted storage? What happens if the application data needs to be accessed or stored at the edge? These limitations can often be overcome by incorporating data security features at the application level in the code, as opposed to relying on third-party services. This requires security conversations to start at the beginning of product development lifecycle and to be discussed at every phase, just like functionality, stability, and user experience. This will save time and money by being proactive instead of reactive to security choices. Security infrastructure and features should support the appropriate software architecture, not dictate it. Part of a software architecture's design and research should include what security tools can be adopted to reinforce data protection wherever and whenever it is needed to be accessed and stored. This way, privacy and security features can be designed into the product by design and by default, resulting in a better data protection without sacrificing user experience and or performance. This also enables organizations to reduce liability and lower the cost of complying with data security and privacy regulations by protecting and controlling data at creation rather than having to find and silo it at a later point in time. When we move data protection to the application level, we have several tools we can utilize. Some of the more obvious being authentication, authorization, source and integrity verification, encryption, and audit trail. Authentication is used to verify the identity of such as a user or device or service. This is accomplished with items such as a username or unique ID, along with one or more of the following factors. Something you know, like a password, something you have, like a cell phone, something you are, like a fingerprint or facial feature. Once someone or something has been authenticated, authorization focuses on determining what rights or permissions an entity has within the system to which they are authenticated. For example, what actions are allowed for an entity, such as create, read, update, and delete. Authorization and related actions can apply to users, data, processes, etc. Source and integrity verification is used to ensure the data source is valid and data content has not been tampered with. Did it come from who you thought, and was it changed in any way? This can apply to any data, messages, files, keys, etc. that needs to be verified. And some of the more common methods of verification are digital signing and message authentication. Encryption is used to prevent unauthenticated and unauthorized entities from accessing and using sensitive data. It is typically used to protect data in transit and at rest, but also can be applied to storage, such as a drive or folder, transmission, such as a tunnel or connection, or objects themselves, such as messages, keys, or files. The more granular the encryption, for example, at the object level, the greater the protection against brute force attack, and the more flexible the application developers have to be able to apply specific permissions. Auditing the actions of entities within your application allows you to keep a record of who did what action or who tried what action, whether it was successful or not. And some examples are who authenticated, what were they authorized to do, what actions did they take, and when did this take place. This is all important if a security issue is discovered and supervisors or authorities require the audit trail, but it also can be used to proactively detect security issues if unauthorized actions are observed. Now let's take a look at a couple of these tools in action to see how they can be combined to protect data within the application. Let's say you have an application where you want to share data between users and you want to ensure that only approved users can access and read the data regardless of where the data resides. And anytime the data is accessed, you want to prove who it came from and that it was not altered in any way since it was last accessed by the sender receiver. The first step is creating and authenticating the users in the application. This can be done by generating a unique set of symmetric keys for each user, and the public keys can then be shared with all users in the system, either directly or through a central key store. You want to use the private key of the sender and the public key of the recipient to perform a Diffie-Hellman key exchange to produce a shared secret, which then can be used to create the symmetric encryption key. Use the symmetric key to encrypt the data that needs to be shared, and then you take the private key of the sender and sign the data. And you want to create an HMAC key. Then you can turn around and HMAC the data and produce the digest. And then you want to encrypt that HMAC key. And you want to take all the relevant information and share that with the recipient. That would be the encrypted data, the signature, the digest, and the encrypted HMAC key. Reverse the process on the recipient side using the recipient's private key and the sender's public key to produce the shared secrets, the same shared secret, and turn around and get your symmetric encryption key. With that encryption key, you can decrypt the data. You can turn around and use the sender's public key to verify the signature. You can decrypt your HMAC key and take the data and the digest, ensure the data hasn't been altered at all since it was generated by the sender. Cryptography can be complicated and perhaps even a little bit scary. And not every team or organization has or can afford a cryptographic expert. However, in today's development community, you don't have to be an expert on everything to create applications with robust and complex features. You can utilize third-party libraries, letting the expert do what they're best at while keeping your focus on what you're best at, creating your own unique software. There are a variety of open source and paid libraries available to handle cryptographic operations. And in general, the free open source libraries tend to require more effort and security expertise than paid libraries do. Libraries, however, enable all crypto processes to be native to your application, providing a lot of flexibility without having to write all the custom code. So now we need to take the data security tools that we've talked about and utilize them at every step of the development lifecycle. As you start to gather and analyze the requirements, the product team needs to discuss all aspects of data security and how it might apply to each requirement, asking yourself, at what point does a user need to be authenticated? Should all users in the system have the same level of access? Is any sensitive data created by the application? If so, where is it created? Where, when, and by whom does it need to be accessed? How about data integrity? If data is not sensitive, i.e. it doesn't need to be kept confidential, does it still need to be verified to make sure it hasn't been altered and is coming from a trusted source? In addition, it's important to take into consideration any applicable regulatory requirements or company-specific policies, as these might drive additional data security requirements. You should also consider business goals and the future product roadmap to make sure a decision made now doesn't negatively impact or limit the future software architecture. Once you have sufficient information to develop and prioritize the security solution requirements for the product, the final decision will be to determine if you will buy or build the data security solutions. You need to make sure the development team has the skills necessary to implement the proposed solution. For example, it may require a more senior security engineer to build cryptographic processes using open source tools. But if you don't have or don't need a full-time security engineer, consider using libraries or APIs that don't require security expertise, and or consider outsourcing implementation to a specialist if the company wants to retain all IP ownership. While not typical, it's critical to design a plan for protecting data for its whole lifecycle from creation to end of life. It's important to identify the potential vulnerabilities in the system, how to avoid them, and finally, verify that they've been addressed. We need to create and document our plan so that both development and QA teams can clearly follow and verify it. However, before development begins, we need to evaluate all proposed security solutions, products, and APIs identified in a requirements phase to ensure they're still a fit. Ensure we have complete environments for both development and QA so that data security is addressed in both phases. Make sure that only dummy data is used in these environments and that developers will not, or better yet, cannot have access to real customer data. Develop code for application security everywhere identified in the requirements and design. Make sure you develop detailed security test plan for each iteration of the software. You need to ensure that QA understands how to test the application level security that's been implemented. And during development, conduct your unit and integration testing with application level security focus, ensuring that data is protected at creation and consumption. And if it makes sense, consider incorporating static application security testing tools to identify some of the more common vulnerabilities, but at a bare minimum, perform manual code reviews to catch errors as early as possible in development. QA should think about the potential security implications of each feature they are testing and incorporate both happy and unhappy path scenarios into test cases. Using these test cases, QA should perform manual or automatic testing to identify issues development may have missed. Performance and load testing should be completed with security controls enabled to ensure they work and do not affect the application's performance. Make sure application security controls are evaluated for usability issues through the appropriate user acceptance testings. And finally, consider whether independent vulnerability assessment of the product is appropriate. Typically, this is going to occur once the application is in a stable state, and future releases will not significantly impact usability or the security of the software. Once the application has been sufficiently tested, you should conduct a pilot deployment of the complete system to ensure the security approach is sufficient and the product works as expected. If everything goes well, then you can execute the transition from pilot to full-scale deployment. At this point, you'll want to make sure that there is an effective plan in place to handle authentication and approval of future application and system updates. And finally, in order to ensure the application is used as intended, make sure to develop training and awareness programs around the security functions of the software for administrators and users of the system, especially if security features are optional or user dependent. Once the product has been deployed, it's critical to conduct periodic vulnerability assessments to ensure that security controls are functioning correctly and effectively. You can also utilize monitoring tools to quickly identify and act upon security violations and unauthorized changes. If appropriate, consider implementing a bug bounty program, because it's got to be better to pay someone to find issue than to have to pay a ransom. Finally, make sure to set up a process for application maintenance that includes patching any and all vulnerabilities, whether in your code or third-party libraries. So let's shift security to the left of our development process. It's time to move away from the typical find and fix methodology to secure by design. We need to make data protection a part of every product and design discussion, just like we talk about functionality, stability, performance, and user acceptance. And by shifting security conversation to earlier in product development lifecycle, software organizations can save time and money on expensive infrastructure, unnecessary services, and costly redesign, reduce liability, and lower the cost of complying with data security and privacy regulations, better differentiate their offerings from competitors, and scale more effectively in the long run without limitations imposed by vendor lock-in and infrastructure restrictions, and sleep better at night as well. Thank you again for your time, and at this point, I'll try my best to answer any questions that you may have.
Thanks, Steve. Just as a reminder to everybody who is on the call today, feel free to submit questions in the chat panel on the right. We'll start going through some of these. And feel free to continue asking, and whip to as many as we can before our session time is up. So one here that got submitted kind of privately, Steve, is what can you kind of better differentiate what you mean by infrastructure security versus application security?
Yeah, so infrastructure security is going to be like if you're putting firewalls in place, things like that. You know, making sure that you're using TLS connections. That's going to be your infrastructure. Application security is like the example I went through there, where you're going to put cryptographic practices within your code versus relying on hardware to take care of it. Does that help?
Great. Next question. You referred to different kind of open source and paid libraries. Can you give some examples of what you are referring to?
Sure. From an open source standpoint, you've got things like OpenSSL, which is good, you know, that's going to be written in C, or you could go, if you're talking language specific, I'm a Java developer, and so on Android, you would know this as well. There's Bouncy Castle that's out there. There's a few things like that. On the paid library front, we'd be glad to talk to you about our solution, but I don't want to do it in this talk here. You can meet us back at our booth. We're actually going to do a demo a little bit later, or I could do a private demo of what we have. I'm trying to think of off the top of my head any other open source ones that I know about. Those are the big ones. OpenSSL, of course, and then Bouncy Castle is on the Java front.
Another question that came in here, what is your take in using mutual authentication or two authentication TLS in real-time HTML5 video applications? Have you tested utilizing this type of feature in those types of video use cases?
Well, we have not done that. We've done a lot of security consulting ourselves, but I don't have any experience doing that.
Next question, will encrypted HMAC key add to end-to-end latency in live migration of workflows?
The only latency it's going to add, you're going to up your payload, because you have to send the key as well as the data. So you get that, and then the additional latency is running the HMAC, getting not the digest but the verification. So you got the digest on the sender side, and you got the verification on the recipient side. So there's a little bit of latency there, but a lot of tunnels now will do that on the fly.
Next question, how do you handle encryption and other application level security functions in kind of limited connectivity environments like IoT, where you maybe have restrictions to access to kind of public internet structure?
In our experience, when you're doing things like that, you need to store keying material locally. So one option would be is to use something like a TPM chip to help protect your keys locally, and so you don't have to go to the key store every time to do that. You can keep your key ring protected, and then the public key material that you need for communicating with other people it's public, so that's not as important. You could use an encrypted database to store that. On small devices anymore, there's quite a bit of computing power on there, but in our experience, that's what we do. Use something like a TPM chip or some password-based encryption to store your key ring locally, and then store things, keep your keys local that way, and not worry about a central key server in that case.
Another question here. Oftentimes, information security and development teams are very segregated in organizations. Who do you recommend be involved in the application security discussions, and do you have any best practice guidance around that?
I think everybody should be involved. It should be upfront. So when you talk about your requirements and you're gathering your requirements, at that phase, you want to have your your information security people on board so they know what you're planning on doing. Of course, you're not going to say, hey, we're going to put encryption inside our application, so we're good to go. We don't need to worry about anything else. You're always going to have your hardware protection, your TLS tunnels, and things like that. But adding it into the the application level just protects the data at that much more. And if it's at rest, no matter where it's at rest, it's going to be protected. But so short answer is they should be involved at the very beginning.
All right. And I think we're at the end of our time. If anyone has additional questions that they weren't able to submit during this talk, we encourage you to stop by the Appsio Expo booth. Steve will be there all this afternoon and portions of tomorrow, and would happy to take additional questions that you might have or discuss any more specific use cases that you would like some guidance on. Thank you all for attending our session.
Thanks, everyone.